Hey Algebra 2 students, welcome back. Today we're looking at 4.1 simplifying radicals. We're going to spend 2 days on this and we're having 2 separate lessons. One to just get our feet wet with the simplifying and then one day to do a little bit more complex stuff. So let's go ahead and jump in. The thing to note about multiplying and dividing radicals is that we can combine radicals if we're just multiplying and dividing. Now, if we do not have multiplication or division like we have in problem 1, what we need to do is we need to have like terms. So like terms apply to the same exact radical. Notice here we have square root 12 and square root 27, which are not exactly the same, but what we're going to do is we're going to try to simplify it and see if it does come out the same when we simplify. So step 1 is we're going to simplify the radical. Now how we're going to do that is one way to do it, but it's a bit clunky, is to use the factor tree. The other way to do it, because we're in Algebra 2, we're going to figure out our perfect squares. So let's just list a bunch of the perfect squares we have. So the first, I don't know, maybe 10. 1 is 1 times 1. 4 is 2 times 2. 9 is 3 times 3. 16 is 4 times 4. 25. 36, 49, 64, wait, I'm missing one, 8, 9, okay, no, 81, and then 100. All right, if you guys could remember these perfect squares all the way up to like 25 squared, which is 625, that'd be like super helpful for you in the future. Otherwise, please just know up to the first 10 because that's super, super important. Okay, so what we're going to do here is we're going to look at our factors of 12. So I know that I have a 4 as a factor of 12. So I'm going to split up my square root of 12 to 4 times 3. And then what we can do here, and you can skip steps eventually. Well, let's do the 27 as well. So I know 27 is 9 times 3. So I'm going to do 9 times 3. Okay, so you can start skipping this step eventually, but for now I'm going to show you the whole thing. So we can split up these multiplications inside. So I can do radical 4 times 3 as radical 4 times radical 3, as well as radical 9 times 3 as radical 9 times radical 3. Now the reason we do that is because 4 is a perfect square, therefore its square root is 2. So I can simplify that. And also square root of 9 because the square root of 9 is 3. Right, so we just changed these two perfect squares and we just did the square root of them. So now I have negative 8, which is 4 times 2 square root 3, minus 3 square root 3. And now that we have like terms, right, we have the same exact radical, now we can subtract. So negative 8 minus 3 is negative 11 square root of 3. Okay, so as you get better at this, you could probably skip this step all the way down to here. But if you need to show all your steps to begin with, then that's probably good. The other way we could get to this same point here would be using the factor tree, right? So let me change colors here. But it's clunkier. So we're going to do 12. We're going to break this down to factors, right? So 12 is 3 times 4. Any prime factor, I'm going to circle. Anything that's not prime, I'm going to break down some more. So 4 is 2 and 2. Those are both primes. So what we do there is we're going to take our pairs, any pairs we have. I'm going to take out our 2. So this one is 2. Any pairs go outside the radical. Anything left over stays inside. So this is 2 radical 3. Notice here, when we simplified, we also got 2 radical 3. And then I guess we could do it the same thing for our 27. Square root 27 is 3 and 9, circle the 3. Then 9 is 3 and 3. So we have 2 3's here, which we can take out. And then we have this 3 left over, so that stays inside. So notice again, that's what we got there. So it's a little bit clunkier because you got to break it down all the way and put things together. But if it works for you, then you can use that to get to this step. Okay. The second one, so this one is not a addition or subtraction, so we don't have to worry about like terms. We're going to multiply these together. So 3 times 7 is 21. And then we have x times x, which is x squared. Now 21, we can't break it down, right? There's no common perfect squares inside of our factors of 21. So we're going to leave 21 as it is. The x squared, though, we can do the square root of x squared. Let's show it out this way. Right, so we can split it up again to 21 and then x squared in separate radicals. The square root of x squared is x. And then we have the square root of 21, which we can't break down into perfect squares. For those of you who want to do the factor tree, 21 is just 3 and 7, right? Those are both primes. Neither of those things has a pair, so we put them back into the radical, which is square root 21. Okay, on to number 3. This one we're looking at square root of 2y squared times 10y, so same idea here. We're going to combine them. 2 times 10 is 20, and then we have y cubed, right, because we have y squared and one more y. All right, so we know that 20 is 4 times 5. So let's skip steps here. So we can take the square root of 4, right? So square root of 4 is 2, that goes outside. 5 needs to stay inside. And then also y cubed, if we take y squared, so 2y's out of there, the square root of y squared is y. And then we just have that 1 left over. So that would be it. Right, for those of us who need to see all the steps, we did this. So we did 4 times 5, y times y times y. So then we said we know a square root of 4. 5 doesn't have a square root. We can take the square root of y squared, but then we have that 1y left over. So this one is 2. Square root of y squared is y. And then we have the 5 and the y still left. So we have 5y inside. Okay. Last one. So this one we're going to distribute. And this is working towards our goal for next class. We just multiply it just as we see it. We just need to make sure that we simplify at the end. So let's go ahead and do that. 3, remember we only multiply the radical with the radicals. Square root 3 times square root of 15 is going to give us square root 45. Again, 3 stays out. We multiply radical with radical. So square root 3 times 7 is going to be square root 21. We already know 21 is not going to simplify, so we're going to leave it as that. But we can simplify 45, right? 45 is 9 times, let's do this, 9 times 5. We know we can take the square root of 9 now, so we're going to take 9 square root, which is 3. So we have 3 times 3. The radical 5 stays where it is. So we have 9 square root 5 minus 3 square root 21. And because we don't have like terms, right, we don't have the same radicals, we can't add or subtract them, so we'll leave them as is. Okay, so hopefully you guys did a little bit of stuff in Algebra 1 with radicals. If not, then we gotta like catch you up, but it's not too bad, right? It does require you to know your perfect squares, or at least how to factor, or how to do the factors of a certain number using the factor tree, if you have to do it. But we're working with small numbers, so we should be able to figure out if we can see, oh, is 9 a factor, is 4 a factor, is 16 a factor, all the perfect squares from the numbers that we're given in our radicals to break it down. I don't think we need to factor tree, and while it does work all the time, I think we should work towards getting better at it because we are in Algebra 2, and you need to know how to multiply and how to do the factors and stuff like that. All right, good job.